All right, so a little bit on cross multiplication. Sure, you guys have done this sort of thing before. So anytime that you have a fraction equal to a fraction or a ratio equal to a ratio, this is called a proportion. And the shorthand is if you have something like this, you can cross multiply like A times D and B times C, whatever's in the numerator here and denominator there. You can set those two products equal to each other. All right, anyway, it becomes useful in solving equations. So all this really is a special case of clearing the denominator, which was something we did last year. So just to show you that the way that we get this result is we take both sides of the equation and we multiply by b and by d. That's the clearing the denominator part. So when we multiply by bd on both sides, what happens on the left is that these two b's just cancel each other, and so you're left with a times d. All right, and then similarly on the right side, the d's cancel with each other, and so you're left with b times c. That's why this is happening and why it's true. All right, let's go ahead and solve this equation. What you could do is cross multiply. So 5 times 9, that can be 45. And I'm going to set that equal to the product of 3 times x. Bam. So we cross multiplied, and now we just solve the resulting equation, which this one's pretty easy. 3 times x, all you got to do is divide both sides by 3. All right, 3's cancel. 45 divided by 3, that's equal to 15. And nothing to it. That's all you had to do for that one. I will mention, if it makes your life easier, if you want to, you could simplify the fraction beforehand. All right. So 3 over 9 could have been simplified down to 1/3, and the numbers would have been smaller. If it makes it easier on you, you can do that. All right, we got that one. This one is going to be very similar, except that we also get to use some distributive property. So we got a fraction equal to a fraction. We can cross multiply in order to solve this thing. All right. What we're doing is we're multiplying both sides by 3x minus 1, and we're multiplying both sides by 5. That's the step that's actually taking place. All right. So 4 times 5, that's going to be 20. And then we're going to do 2 multiplied by this whole thing. All right. So I'll write it in steps here. 2 multiplied by the entire 3x minus 1. Excuse me. So this just tells me that I have to use the distributive property on the right-hand side. 20 is equal to, if I distribute my 2 inside, I get 6x minus 2. And then it's a little two-step equation. Add 2 to both sides. 2's cancel. You get 6x is equal to 22. And then we'll divide both sides by 6. So this would be our answer. If I simplify that down, it's going to be 11 over 3. And then as a decimal, I guess, 11 divided by 3, that's going to be 3.66. So you can put either answer here. It's fine with me. All right. And that's all there is to it. Now, I will mention, if you want to be clever about these, sometimes you can be clever. All right. So let me just start over on this equation. Two over 5. So by being clever, what I mean is hopefully you notice that what I could do is I could take this fraction over here, and if I multiply it by 2, all right, if I multiply it by 2, this is what I end up getting. 3x minus 1. I get 4 over 10. All right, if I multiply the top and bottom by 2. Now, the only reason I do that is so that I can see like this nice, very true equality that's happening. I got 4s in my numerator. What that means is that the denominators must be equal to each other. So what I could do is I could just solve this equation, 3x minus 1 equals 10, and that could be the only equation that I focus on. All right. So sometimes you can play little tricks with the system like that if you want to. All right, that's it. Of course, you would plus 1 on both sides and then divide by 3.